Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so question 8, we're doing the 2020 paper 2 solution set, the paper that didn't happen last year but was given out in November. So question 8, the table below shows data measured in kilotons on how municipal waste was dealt with in Ireland from 2005 to 2011. Don't worry too much if you don't know what's meant by municipal waste or kilotons, okay? Try and just take away the question. So we have a number of years, 2005 to 11. We have total waste collected and we have waste sent to landfill. Okay, the first part says find the difference between the percentage of the waste collected which was sent to landfill in 2005 and the percentage of waste sent to landfill in 2011. Give your answer correct to decimal place, one decimal place. Okay, so they want us to compare 2005 with 2011. Okay, so the percentage of waste collected which was sent to landfill. Okay, so to get percentage, you take what you want over the total. Okay, so for 2005, it would be 1833 over 2779. Okay, and you'll notice if you put that into your calculator as is, 2779, you could get it as a fraction or a decimal, okay, not as a percentage. Okay, so how do we convert to a percentage? Well, you multiply 100 by 100 or multiply by 100 over 1. Okay, and that's what converts it to a percentage. So I'm getting 65.96% for that, 9589 if you want, 9589, okay, or 65.1 decimal place. The 5 rounds up the 9 to 10, okay, which rounds up him to 66. Okay, or find the difference. And you know what? I'm going to leave it at 65.9589 for 9. Okay, so that's 2005. Let's have a look at 2011. So the percentage sent to landfill over the 2547, the total waste collected, again multiplied by 100 or 100 over 1. That's actually the same thing, so it doesn't matter. 1344 over 2547. And again multiplied by 100, and as a percentage that is 52.7679%. So you can see I take loads of decimal places so that I end up with no rounding error. Okay, and then I round at the end. So the difference is 65.9589, take away 52.7679. Okay, let me put them into my calculator. 65.9589 minus 52.7679. And I am getting 13.191 for that. Let's round it up. That's going to be 13.2%. Okay, so that is the difference. And I'm putting a box around it so it's easy for my corrector to see. Find the mean amount of waste collected each year from 2005 to 2011. Okay, so a bit of stats in this one. The mean. The mean is another word for average, okay? So to get the average, we add all up and divide by the number of numbers, or the number of years in this case, okay? So find the mean amount of the waste collected, so not landfill, but waste collected from 2005 to 2011. Okay, well, let's add. Okay, so sorry, now I'll be flicking over and back. So 2779 plus 3100 plus 3175 plus 3104 plus 2825 plus 2580 plus 2547. And we divide that by the number of numbers. So 1, 2, 3, 4, 5, 6, 7. Okay, so let me pop onto my calculator. So I have 2779 plus 3100 plus 3175 plus 3104 plus 2825 plus 2580 plus 2547, and that's all over 7. And I am getting for that 2872.857. And it says give your answer correct to 1 decimal place, so I need to look at the second place. So 2872.9, and I'm going back for units, kilotons. Okay, so a couple of things just about this. Why did I write it all out? Because it does take a couple of minutes to write it all out. Well, the reason I do that is because I, as a person, make silly mistakes. Okay, I take numbers down wrong. So having it all written out like this shows the corrector that I know what I'm doing. Okay, I know how to get the mean of a number. So therefore, if I write a digit down wrong, or if I enter it into the calculator wrong, it becomes known as a slip. Okay, so it's not done wrong per se anymore. It's just you made this tiny little blip. Okay, and you'd normally lose 1 mark for that. Whereas if I just put down an answer and I haven't shown where it came from, I'm not giving the examiner anywhere to give me marks. It doesn't know that I know how to do it because I haven't shown them a method. So if I get it wrong, the examiner can't really give me marks. Okay, so if you get it right, you're normally okay. It's just if you get it wrong. And remember, in an exam scenario, we tend to be nervous and we tend to do more little slips. Okay, so that's the first point I want to make. Second point I want to make is have a look at your average you got. So an average is like as if you mixed everything up together and you looked at what was kind of the value in the middle. Okay, so your average value has to fall between the smallest and the largest value. Okay, so 28, somewhere between 25 and 31 feels right. If I had a load of numbers up around the 3000s, then I'd expect this number to be closer to 3000. But the numbers are kind of symmetrical. I have a few low ones, few high ones, so I'm not surprised then when I see the number to be nearly in the middle. Okay, so I'm confident that that number is correct. Okay, next part. The mean amount of waste sent to landfill in the 4 years from 2009 to 2012 was 1398 kilotons. Find the amount of waste sent to landfill in 2012. Okay, so we know from the data what was sent in 9, 10 and 11, okay? Sent to landfill, sorry, I'm over here now. Sent to landfill, okay? So that was sent to landfill in 2009, 10 and 11. Now we don't know what was sent in 2012, but we do know what the average ended up being, okay? So the method I'm going to use, okay, or the method you would use to get a mean amount is you would add 2009 with 2010, with 2011, with 2012. And you would divide it by 4 because you've 1, 2, 3, 4 data points. Okay, and it's telling you that the answer to that is 1398. Okay, so let me put in the numbers that I have. I don't have 2012, but I do have all the rest. So let's put those ones in. So 2009 was 1724. 2010 was 1496. 2011, 1344. And 2012, would it make more sense? Maybe it would if I called it X. Okay, of course you can leave it as 2012, but maybe it would make more sense if we called it X. Okay, so what I'm going to do is I'm going to multiply both sides by 4. You see the way he's divided by 4, okay? So if I multiply both sides by 4, okay, why on this side? Well, because I want to get rid of the fraction. Okay, why on this side? Well, what I do to one side of the equals to sign, get rid of that one in case you're getting confused. What I do to one side of the equals to sign, i.e. multiply by 4, I have to do to the other. Okay, so what I end up getting is 1724 plus 1496 plus 1344 plus x being equal to, so on my calculator I'm going 1398 multiplied by 4, 5592. Okay, how about we add up these three numbers? So 1724 plus 1496 plus 1344, and I am getting 4564 plus x being equal to 5592. Okay, so let's subtract 4564 from both sides to get rid of it from the left hand side because we want to figure out what's x. So 5592 minus answer is 1028, okay, which is equal to the 2012 number. Okay, so it all comes down to this. Your method, what would you use to give you the mean, okay? And on the year you don't have, just put in that number x if you wish. Part B. The table below shows the percentages of all of the different types of energy sources used in each of 13 European countries during 2014. So we're energy sources. Okay. What percentage of the energy used in Denmark in 2014 was renewable? Okay, so where's Denmark? Denmark. Okay, so renewable, oh yeah, okay, so it's blank. Okay, well, percentage, I presume, has to add up to 100. Okay, let me just double check there for Austria on the top. So 25 plus 31 plus 8 plus 17 plus 13 plus 6. Yeah, and not surprising, I get 100% across there for Austria. Okay, so this is all of the energy uses in a country, which means that Denmark needs to add up to 100. So let's go 31 plus 11 plus 13 plus 12 plus 13, and let's see what we get. So 31 plus 11 plus 13 plus 12 plus 13, and I'm getting 80. Okay, so 100% minus 80% is equal to 20%. Okay, so I can put the number 20 in there. Okay, so that wasn't too bad. Name the 4 countries that used a lower percentage of renewable energy than Ireland. Okay, where is Ireland? Ireland is 6. Okay, 4 countries that used a lower percentage. Okay, lower than that. 4, 2, 4, and 5. Okay, so Cyprus, Luxembourg, Malta, and the Netherlands. Okay, that's okay. Name a country which did not use gas as a fuel source. Okay, so who did not use gas? Well, any of the zeros. Cyprus or Malta? So what is this question examining? It's examining your ability to read a table of data. Okay. There's no point in being able to generate tables. It's important that there's a lot of data out there on the web. It's important that you're able to read data. So this is what this question is examining. So Cyprus or Malta uses no gas. Part 4. The table below shows the percentage of the different types of energies that were used in Ireland during 2014. It also shows one of the angle in a pie chart to represent this data. The angle for renewable energy, 6%, is 22 degrees. Complete the table to show the angle for each energy type. Give each angle correct to the nearest degree. Okay. So what they've done is they've taken Ireland's row here, okay, 6, 42, 13, 24, and 15, and they've just written them downwards. And they'd like you to represent the proportion of each energy source on a pie chart. Why? Because this is a pictorial representation of the data. And a lot of people find graphs, this is an example of a graph much easier to read and see than they do this table of data. Okay, so where did the 22% come out of? Okay, so always when I am doing a question, I always try and figure out, well, where did the 22% come out of here? Because if you can figure out the method they used to get that 22%, then you can apply the same method all the way down here and get the right answer. Okay, so it comes from this percentage column, okay? So for renewable, what they did was 6 out of 100, or 6%, of 360 degrees. Now, where did I get 360 degrees? Well, in a pie chart or in a circle, it's 360 degrees, okay? So if you can imagine a protractor, you've often seen me draw on a protractor, so that's 180 degrees, okay? But you're of course under it, you have another protractor that's another 180 degrees. So in a full circle, you have 360 degrees. Okay, so I'm getting 6%, 6 over 100 of 360 degrees. Of course, you can divide 360 divided by 100 multiplied by 6, or you can do 360 multiplied by 0.06 if that's how you do percentages, or whatever way you like. On your calculator, you can go 6% multiplied by 360. But either way, 6 over 100 multiplied by 360 is 21.6 degrees, and to the nearest degrees it's 22. Okay, so that's where that came out of. Why am I writing it like this? Well, I suppose it's good practice for pie charts. So if it was a survey of 50 people and 5 people cycled to school, I would put 5 over 50, so 5 out of the total multiplied by 360 degrees, okay? So it's like a proportion, 5 out of the 50. Here I'm doing 6 out of the 100%. Okay, so it's just, it applies, that method applies to any pie chart. So if we do oil next, that is 42 out of the 100% multiplied by 360, so it's nearly half. So I'd expect it to be up near the 180 degrees, okay, not quite, but up that far. So I'm getting 151.2 degrees, so to the nearest degree, it's 151. Okay, solid fuel is 13 out of 100 multiplied by 360 degrees. and I am getting 46.8 or 47 degrees. I then have gas, and of course that's 24 out of 100 times 360 degrees. And that works out at 86.4, which is 86 degrees. And electricity is 15 out of 100 multiplied by 360 degrees. And that is 54 degrees. Okay, so a good check, of course, is to add all of these up. So 22 plus 151 plus 47 plus 86 plus 54. I'm just going to change that little degree symbol there because it looks a little bit like 540. And you get 360 degrees. Now you might get 359 or you might get 361 because we're rounding, okay? You won't in this question, I just mean in a different question, you might get it to round slightly different. You shouldn't, you should get around the 360, but there you go. Okay, so I'm just going to grab a protractor now to do my angles. Okay, so I've just grabbed a mat set there, so you'll all need a mat set obviously for your exam. So I have the protractor with my angles on it. So you always start drawing from this line. This is typically the start line. Okay, so you put the bottom line of your protractor. So if I can draw my protractor down here. Okay, so that bottom line that's drawn onto your protractor, match that up to here, okay? And we're going to measure around this way. So you need to be measuring, you need to be starting on the numbers that start at 0 degrees, okay? So on my one, it's the inside one. So put this line here down on this line and see, can you see the 22 degrees? So we're starting at 0, okay? So my next angle I need is 151. So I've turned my, I know you won't see it on the screen, but I've turned my tablet a little piece around. I'm now going to put the bottom line of my protractor onto that line there. So that's like my new starting line. And I'm going to measure 151 from there. Okay. So I don't know how well this is going to go on screen, but anyway, we'll give it a try. 130, 140, 150, 151 is here. A pen would have been handy rather than the laser. Let's try it again. 150. One is about there. Okay. So I then get a ruler, and from this center point here, I then draw out towards the purple dot I had there. Okay, so that angle there is 151, okay? And I write into him oil. Okay, now again, my iPad now is completely upside down because I need this to be my starting line. So I need this to match the bottom of your protractor. Okay, so what's my next angle is 47. So again, down goes the protractor onto that peachy line, and I'm looking for 47 degrees, and I'm over here with my protractor, and I know it's hard for you to see, but anyway, so I'm somewhere here. Okay, so I slipped a little bit there. So 47 degrees. Okay, and that is solid fuel. Okay, the next angle I'm looking for is 86 degrees. okay, which is nearly a right angle. So that's what I'll use as my gauge that I'm right. So again, turn your page fully around and use this black line now as the starting line here on your protractors. Your protractor goes down. I lost my page. So turn it around again. That black line becomes my starting line here. So my protractor is going down onto that black line, and I'm going to measure 86 degrees, which is practically a right angle. So 80, 85, 86. So I'm somewhere down there. Okay, so 86 degrees. My iPad didn't like being written on upside down. 86 degrees. And it is gas. Okay, and then of course this becomes my starting line again for my next one, and I'm hoping that there's 54 degrees here. So let's put down my protractor and let's see what I have. It's a bit like 52 degrees, I think. I'm not surprised doing it online because it keeps slipping, but more or less that's my electricity. Okay, so I hope that makes sense. Let me just fill in the table here. So that's the table and the percentages and how you work them out, and that's filling in the pie chart. Okay, so I hope that makes sense. It doesn't come up that often, but it does come up. So make sure you can do the pie chart. And if anybody needs me to do any other one and is working on a question, just suggest a question to do in the comments. And of course, we can do it.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.